Hi, I'm Lars. Welcome back to the shop. Hope you're having a good day. Currently what I'm trying to do is I'm trying to get my wasteboard that I just cut mounted into the bay of the machine. So I'm going to throw the camera up on top to show you guys what I'm doing, and hopefully this will make sense. So I'm hoping you guys can see this. I'm hoping everybody can see this, but what I did is this board, the wasteboard itself, is 49 inches wide. So I put the wide part from the front here to the back. And I cut the 4x8 sheet of MDF, the 3/4 MDF, perfectly in half. So I've got like 48 1/4 going left to right. Okay? So that's this way. Left. So that's the right, this is the left. This is the front left corner. So back and to the right. So 48 1/4 going this way, 49 going that way. I took a 1/2 inch off the front and a 1/4 inch off the side and made that my zero for the machine. Now the Z-axis is going to be zeroed up way high, but this is my X and Y axis. Now again, with just like with everything else with squaring, I need to get this corner mounted before I can start adjusting things. Otherwise it's going to move all over the place and I gotta go back and recheck. So what I did to do this is I took my square like this, and initially what I did, I tried this and raised up the Z-axis like that, grabbed my level, set it against the side of this, got it all lined up, and so that the level would be on this line, and turn my Jenny bit to touch on both the sides. And then I thought, well, let me just extend my Jenny bit down, and that's what I did. So now I can put this right down on here and see that the edge of it's on that line and the other edge is on that line. So we are good. That would be ground zero, origin 100%. So I'm going to drop a screw in here, and then I'm going to go to the right side. So as you can see, the 1/4 inch on this side is giving me a little bit out to the edge of the board, but I don't think I will ever be drilling out here, or I don't know, I might be, but I'm still on the wasteboard. What I need to do now is I need to move this wasteboard forward because that line is actually in the middle of the bit. So I'm just going to come back here and tap it a couple times. This up. Bring it down. Okay, so this is another one of those materials that you want to step drill. And I'm not going to show you why because I don't want to destroy my MDF, but someplace, you know, yay here, it should be good. You know, you want to stay off the edge the best you can. But the same respect, you're going to be on the edge. You're going to be on the edge when you get to the front of this, not on the edge here. So try to keep your bit as straight as you can. The other thing you need to know about MDF is it's not like plywood. If you have never used it, played with it before, you need, and you want to countersink a screw, you need to drill it out, because if you don't, this will all just split when you get down to where you want to be. I wish Grip Fast sold these locally, but they don't. I had to special order these in, but these are great little screws. And if you guys have ever listened to my channel, I really do not like Phillips heads, but especially for something like this. Okay, now that's secure. I'm going to get the rest of these screws in the front and tack a couple down the side, and then call this a day. And be careful putting these screws in too, because if you go too tight, MDF is like glass. That's the best way I can explain it. When you're carrying it, you want to carry it vertical. You don't want to carry it flat. A little bit of a bump, shake, whatever, and it will split right in half. It's not as bad as particle board. It is really dense material, but I'm not a big fan of carrying it around or moving it or doing anything like that. So, all right, on to the back. I'm a developer, and so before I like to let my code just go out into the world, I like to test it. So right now I've got a piece of 3/4 inch plywood and another piece of 3/4 inch plywood to keep this bit at least 1.5 inches away from the top of my wasteboard. All right, I'm only dropping, I think this program only drops it down like maybe 1 inch or something like that. So I got to double check all this. But the first thing you need to do is on your probe, which these cables are really long, and I can understand how people get these things broke real easily. This sets on like this. Okay, the little dot goes up in the top right corner. So it doesn't matter what side you put it on. It's just this is how it sets. It's got a little mill out in the back, so you can catch the corners here, and that they'll get that corner to line up with this. So if you're setting like this would be my x-axis here. So you want to use the back of your caliper and go across until you touch, and that gives me a reading of 0.213, looks like 6. And I've got mine set to 213550, which is pretty daggone close. So I'll make sure I'm not off. Looks like it's 2.1325. So I've got my offset here is 0.213550. So I need to change that. 250. Then my Y offset is the opposite direction. And that measurement's 2.1205. 0225, I believe. .21250. And then you need to measure your Z, which is the thickness of it, which is a lot easier. It's 0.5900. So that's good. So the next part of this, you need to hit Save Settings. Now you only should need to do that one time. And the way that you use your probe is you put the magnet on the bit, and then you put this in here, into the corner, the front, wherever you're centering off, wherever your program says to center off. If your program's centering off in the center, I haven't done one of those because I usually use this, but I guess you're supposed to turn this upside down if you're just looking at the center. And those are kind of things, if you were making like a tray that had grain in the middle, like say you had like mahogany or walnut here and you had maple on the outside, that you'd want centered, so that's why you would center off in the middle. But for what I'm doing here, I'm doing this corner because I'm going to be drilling these bits in, these holes in here. Let me get this guy as square as I can. Alright, I'm going to put my finger on that. So again, this is setting down in this front right quadrant of this block. So I'm going to touch this at the top, and as soon as it touches it, it's going to get an electrical charge, going to complete. And it's going to come down this side, and it's going to come in and touch, and it's going to figure out where the x-axis is, minus these calculations at the top. Now, we need to raise that up, bring it over top of this, and then bring it down. It doesn't need to be anywhere in particular. At least nothing that I've seen does. And then tap the center one. It'll touch and it'll set your Z. Now, you can pull this off of here, set it off to the side, and we're done with that part, exit probing. Now you can go to program and MDI, jump to line, start from line 1, can't read file. Oh, that's always good. So let's load the file back in, jump the line, back up, let's go to 1, start from line, work position 000, feed rate's 30 inches per minute, tool number 1, spindle's off, coolant and missing is off, going to hit exit, and I'm going to hit let's go, and I'm going to move this out of my way. And this is what it's supposed to be doing right here. So it would have drilled a hole, and it'd be drilling this hole, just like it's doing over here on the screen. So I'm going to run this through the entire thing and make sure that they are where I want them to be. And so far they are. So this is a good test. And then I'll replace the bit with an actual drill, just to have it drill through, because I don't think I want to waste or I don't know what's going to do to the Jenny bit, the mill. The holes that'll be drilled will go right through my wasteboard and straight into and through the table. And T-nuts will be put on the bottom. These will be used to anchor down clamps and whatnot. And this is something that you can tell that the water-cooled spindles are considerably quieter than a router. Is it worth the extra $1,000? To me, it actually is. That looks like that came home pretty hard. Don't know what I think about that one. So that just got done running, and I don't know if you can tell it's not, but right here, this is definitely more being cut off. Then as you come down to the side here, it literally disappears. And you can see this here because I still have a pencil line down through here. So there is definitely a little bit of waver in this board. Now when I did measure this board, like this side of it was like 0.77, and then there was a spot in here, it was like 0.76 and 0.7495. So these boards are not perfectly flat, okay? My torsion box is level, so this is something that I guess can happen. It's wood, I don't know what to say. But I'm going to keep on kicking this thing down another 30-second every time until I'm actually cutting all the way across this board. There's also a spot there like this side on the left side over here. I don't know if you can see this, but all the way up, this cut all the way up, but on the right side I got about, I don't know, probably about 2 feet, about a foot and a half from the back. Then there was a dead spot, and then there was like maybe a foot and then another dead spot. So it's not uniform. That's why we have to surface boards. So I'm going to drop this down another 32nd of an inch, and we're going to run it again. So this will be an easy change. This is just going to be the 32nd plus the 32nd is a 16th. 0.625. So that should take it down another 32nd. Now, I'm fairly certain I'm going to have to reprobe this thing. I don't know if I do or not. There's really nothing out there, but since this is my spoil board, until I start screwing around with stuff, this is something that's pretty important to me, and I don't need it going all over the place. I'm just going to touch this off again. And it's not like it takes a lot of time to do, so gotta go back to line 1. Well, something I want to let you guys see at the end. I changed the coding at the bottom of my application, the G codes, and I'll put them in this description. What I do is I raise my spindle up to 2 inches. So now, first thing I do is I turn it off. And then I turn off my coolant with my M5 and 9, then I raise it up, and then it goes back to 0. It just happens to be at 0 right here. But I do that as a safety precaution, because when this thing's running out in the field, okay, so say it was out here running in the field over something, and you've got to hold something down because you notice it was being moved, or you got a clamp that you had to add in, and you just accidentally cross that line that it's going to come back with that clamp, you're going to run right into this. All right, and that's not a good thing. So I like to raise this thing up above whatever I'm cutting on, you know, a couple inches. You know, if you can go 3 inches, that's fine. Do 3, 4 inches, whatever. Just kill the spindle, then raise it, and then move it. And currently at the bottom of the G codes, what happens is it raises it to the safest point, which right now is 0.2 setting on mine, but I don't want my machine going up and down like this every time it cuts something. I don't want it to go up, you know, 3 inches. So I just add that code in. It only takes a couple bits, you know, a couple seconds to get it added in. All right, so let me get this set up for the surfacing, and then I think this is going to be a good thing. All right, just like before, loading the file. This is one here I called spoil board. That's it. I'm going to go to edit, page down. I can get this right. 625 space 0625 is, whoops, that would look a little weird. 625 is 1/16 of an inch. If it was 0.625, that would be 5/8 of an inch, so don't do that. This is the code that I was telling you about. Okay, Really? Really don't like this interface too much. Right. So the code I was telling you about starts at right here. This N58G00, that is coming back to doing my surfacing. So the one that's the next one, G2590, I bring this up to the safe mark, 0.200. The M5 turns off my spindle. That's why you see it go and slow down. And then the M09 turns off the coolant. Then I take it up to 2 inches. And then I zero it to 0.00. And then the M30 means I'm done with everything. So like I said, I'll put that in the description. And then we'll save that because I just changed the, make sure I did change that. Yeah, to 1/8, otherwise this would be a really short run. And then I got to go to probing again. Like I said, I don't know if I need to probe this every single time, but this, like I said, this is my spoil board, and I do not want to screw this up. Oops. Let's exit that. Let's do that again. Again, no, see, that's not, it's going too far. Didn't go far enough back. So this is something you really got to be cognizant about. So let me get this back over here. Okay, I'm trying to get the bit, the tip of the bit. I know it's probably not even needed here, but you got to touch it. And then it's got to come past here and then come down. If you start this too far back, it won't travel far enough down. If you start it too far over there, it won't travel enough over. I think that's what these 1.25 means. Is how far it'll travel, but I haven't done any experimentation on it, so I really don't want to comment on that too much. That didn't feel good. There we go. The reason I said that is because when it hit it, this is not setting flat here, and it kind of rocked a little bit, so probably would be better if I held this down in the back side. There we go. Now it's not going to bury it here. Exit probe bearing. Go to program, jump to line. Again, I don't know why I need to do this every time. Whoa, left the magnet on. That's not good. Now that the board is all surfaced, the next thing really to do is get your homing set up. Get your soft limits put in place. So I'm going to explain a little bit about how these limiters work and how the inputs here work, and not a lot. Not going to get really in depth in it because honestly I don't know really in-depth stuff about it yet. But what I know I will share with you guys. So, let me kick this back around here. Let's see if I can zoom in on this. Alright, we're going to finish up this video now that everything's been The wasteboard's been done, which I'm going to tell you guys, it is a mess. I do highly recommend getting a 2-inch cutter. The cutter that I used is from Align Carbide. This is a 1-inch. I got it off of eBay because I didn't know about Align Carbide at the time. Just going to let you know, this was like $22. If you go to Align Carbide, the 2-inch was not out on eBay. I couldn't find it anywhere. I got pulled down a rabbit hole into eBay. That's how I ended up finding this. But the 2-inch is like $24.99. Well worth the amount of money. It took me about an hour and a half to get this thing, get the wasteboard all leveled out. With the 2-inch, it would have been done in half the time. So very much well worth it. It does make a mess. Some people that I've seen on the internet, what they do is they go out and they run their wasteboard program to surface it. They leave the shop and then they come back later. I did not do that. I'm kind of glad I didn't. MDF was, I mean, I had a pile of MDF on my table, 4 inches piled up, where I just kept on sliding it back, trying to build a wall to keep it from being thrown everywhere. Dust boot, highly recommend for doing that. I do not have one. Okay, so enough of that. Let's look at what I want to talk about here, and I think you guys will probably want to, I'm going to zoom in on all this because I don't have any kind of way to screen in this. All right, so we're over here on F1, right here. And I'm going to go down to homing, and you're going to see Z, X, Y, directions of inversion are X, Y, and B. Now, your Y and your B are that they have to be linked together. All right. So if I was to take this off, take off the B, if I could click it. If I was to take off B, that is my right side Y rail. And if I do not invert this, what will happen is instead of positive going away from me, the B will be negative going away and positive coming forward, and the Y will be positive going away and negative coming forward. So they'll literally rack like this, okay? And that's not what we want. We want them to stay together. So always keep these guys inverted. If I can get this to, it's a little bit cold here today, so this might take a little bit of time. Your homing feed rate, right here, the homing feed rate, when the machine came in, it was set to 20, which was way too slow for me. I set it up to 80, but you could probably set it up to about 300 or whatever. I've seen people set them up to 300, but these are people that are a lot like me that like to get your bit up away from all your clamps and all your stuff, your probes. I just saw a guy on Facebook last night had a probe and it went right in and grated across it. Not a good look, but that's what happens when you don't get your spindle past your clamps before you lower it and turn it on. These are pull-off distances, and I'll explain that in a minute, and then here's your homing position. One thing I really want to make really clear about these screens, if you haven't noticed it, your X, otherwise your labels for all of your fields are on the right-hand side. Now, I do not know why that is. I have no idea, but when you're looking at this, if you don't catch it, you're going to think your X is this field when it's really the field before it. And I know that makes sense right now to go, oh yeah, well that's obvious. It's not, because if you're in the middle here, your brain, for intuitiveness of all applications that are run on computers, Y would be that next one over. So be real cognizant about how you put these in here, all right? So don't make your X this box and put your, because I have 0.25 as my X, and then make this your 0.5, because that's going to end up being Z and this is going to end up being Y. So that's one thing you really want to look at. I've got request home stop after E stop press all the time. Now you can take that off, it's not set. Request home on startup, and that's good. Now, at the top, the homing sequences are, I want to do Z first, because think about it, these guys are machinists that do Masso. Get your spindle out of the way. First thing, get it off your work, and then get it off your board, and then bring it forward. And notice Y and B are always there. So, like I said, be really cognizant about when you're writing, when you generate your post-process, your G code, or whatever you want to call it, that you look at the beginning of it and the end of it. A lot of the stuff that Carveco makes, or VCarve, or whoever, they start to spindle up, and then they take off into it. Okay, they start it up, drops down to 0.2, and then takes across. That doesn't necessarily clear your clamps, because guess what? Your Z, I'm going to back this out some, your home is right here. All right? Your work home is out in your field someplace. You might have a clamp setting near that. You might not. I don't know. You might be working on something that's 24 by 24. Like I'm about to put something on here that's 24 by 48. All right? And I don't know what's going to happen during this. I really don't. I might be halfway through it and have to throw a clamp right there on the home. But if I get my spindle out of the way and bring it back, you're fine. So I'm going to get off that soapbox, but okay. So the first thing we want to do is we want to go to X-axis, and you got to double click on it, and you'll see that my travel minimum is 0.25 and my travel maximum is 48.031. Now, when you get this from Onefinity, you're going to have travel minimum of 0 and your travel maximum is going to be that 48.031. So write that number down, 48.031. And then what I want you to do is click on the travel minimum and put in here -100. I want you to go down here to travel maximum and make this guy 100. And then hit save. And then I want you to go into Y and do the exact same thing. -100. Write that number down. Might not be the number we want to go with, but you know, that's what it was for the person who tested your system out. Remember, these are probably things that they just hard code in. So this is -5.90 is your travel minimum. So make that which for your travel minimum for that is the higher point on your Z. So this is your minimum, down is your maximum. So let's make this here again -100 and make this here, you know, 100. And then hit save. Next thing we need to do is go back into homing, and we need to set the home positions to 0. All right, so 0, just get rid of your whatever number if you had any number in there, and turn that off and hit save. Now we go back to jog and probing and move this back someplace, and going to go to setup. You can see here on the screen it'll be right here, the input is low. If I take a screwdriver and break the beam, you'll see it'll kick high. Now what that'll do is that'll tell over here in homing to stop moving and then do a pull off distance of 0.01969, and that is for every one of them. So you'll notice your machine will come forward, it'll go bump, and then it'll back off a little bit. That's what it's supposed to do because of these pull off distances. You could change these to do whatever you wanted to do. All right, I'm assuming you could, you know, if you wanted to change them. So let's go to program, jog and probing, and double click the machine ready, and that will home. And you'll notice it'll hit. Let me run that again on the spindle, and you'll see it vibrate a little bit. Let me back it back out. Okay, so your X, your Y, your Z, they're all 0, so we can 0 all these guys out now, and that is your home at this point in time. Now, personally, I don't want that for my home. I want my home, because otherwise this is going to drop down, it's going to hit right here, and it'll be above my screws that are in the front of the table. So mine will end up hitting right here, and it will be above the screws in my table. So I don't want that. So I'm going to go back to homing, double click, and I'm going to go in here and I'm going to put 0.25 for my X and 0.5 for my Y, and then I'm going to go back to jog and probing. Now, as you can see, the X, Y, and Z are all set to 0, 0, 0. If I do a home, now it's at 0.25, 0.5, exactly where they're supposed to be, where I want them. All right. So the next part is to see how far back how far back do I want to take it. So at this point, well, before we go there, the next part is to go into the X-axis, and my travel minimum for X is going to be 0.25 this way, and I'm going to save it. And my travel for Y is going to be 0.5. Let me put that in, 0.5. I'm going to save it. Now, I can't go any further back than that. That's called a safe limit. All right? So I cannot go any further left. I cannot come any further forward. So it will stop my machine from crashing into the limiters, if it's coming full bore, which could happen. Anything can happen with CNC machines. All right, so let's move the Y back as far as I can. Okay, as you can see, my Y is at 48.9259. So that is beyond the range of my spoil board. I don't want it to be there. I want it to be, you could go back, you could take a look at it, you could figure out what is the exact distance you want to go. I'm probably never going to cut anything back there. But what that'll do is I need to take this number, say 47.9, go over to setup, go to my Y-axis and say, let's just round that up to 48. 48.0. Now, if I go back to jog and probing, all right, I can't go any further. I cannot go any further. In fact, this light lights up when you put your finger on it and says limit. I don't know if you can see that. It says Y limit, Y limit, Y limit. So that's as far back as I will be able to go. The next thing is we need to kick across to the X side. I don't want to crash into that side, because when it crashes, you get motor errors. So let's bring this back forward. Notice my safe limit here was 0.5. So let me hit Y at 0. In fact, you can type on here and go 0.5 and then hit enter and it will set. So now on the Y side, I'm going to go over and show you this on the X side. If you look at this is over here on the edge. I don't really want it that far, so we're going to move it in. Maybe that far. Just enough to be off the edge of that. Also, you don't want it to be crashing into these bolts, and that's when you hear a crash. That could be hitting it. I don't know, but that's about where I'm going to put mine. So that number is 47.3. So if I go back to setup, go to my X, and we put this guy in to 47.3, I guess that's fine. Yeah, let's go set 47.5. So that's all my ranges now. Now, no matter what I do, I'm cruising along where I want to go. The next thing, so let's home this guy now. The next part of this is to get your Z-axis set up. So the first thing you need to do is take your Z-axis and bring it to the top, as high up as you can. You could hit home, it'll run all the way up. The sensor will click it. Z will be 0. I suggest zeroing out to 0. And then first step is to bring this guy down, and don't just run it down, because it will go right through your board, and make it touch the bottom of the top of your spoil board. Okay, so the number I got is 5.0. I'm going to do this right like this. The number I got is 5.0203. 5.4203. Now, that number is the number for the bit that I currently have in here. So if you're going to be switching bits in and out, you know, figure out which is your shortest bit. Otherwise you won't be able to cut it. So find your shortest bit. This is what I do. My job comes in, I might have to be running a 1/32, I might be running a 1/8. Okay, the 1/32 is going to be shorter than the 1/8. So I do this for the 1/32. If for some reason the 1/8 buries itself into my spoil board, my waste board, I'm going to have to deal with it. But this is mainly to protect my waste board. So I go into setup, I go down to my Z-axis, and I take my travel maximum down to 0 because it really can't go any further than that. And this guy here, I'm going to make negative 5.3. No, 5.4. So negative 5.4. Maybe 5.4. You could say 203, but 5.42, 5.43 should be fine. I'm going to make this right now just negative 5, just to show you what happens. So if I home this, everybody's good. Okay, so everything got home, went to 0. So I'm going to take this up to 100%. I'm going to run this thing down. It stops at negative 5. So this is stopping my job from burying itself into the spoil board, busting a bit or whatever, because you could hit a screw or whatever. All right. If you don't care about your spoil board, I would at least suggest put that value at the top of your T-track. All right. Every time you run it, put it at the top of the T-track. That's what I would do, but I don't have T-track. So at 5.0, so my number was 5.4203. So I'm going to go back in here for right now, and I'm going to say 3 or 4. Sorry, 4.43. 5.43. That, if it does get into the spoil board, that's not really going to do much to it. So I'll be fine with that. There's one more thing that we need to do here. I think it's in general settings. Here. When you get your machine, disable soft limits is turned on. Now this disables your soft limits for your jobs. All right. I don't know why you would want to do that unless you've got a job piece that goes further and you want to push those out. But if it is, you should be adjusting your soft limits anyway. This should be something that you are thinking about to adjust, because I think my spindle will go back to like 50 inches and it will do like maybe 45 and a half, 45 and 3/4 to the sides. I don't want it to go that far, so that's why I keep my soft limits enabled for my machine. Now, a second thing here is disable hard limits. I don't think I want to disable my hard limits either when I'm running a job, because this only happens when you're running a job. This doesn't actually do this when you're just moving it around. So those are my 2 cents. If there's anything in this video that I misspoke about, or you guys want to talk about, or some other way that somebody knows how to do this stuff, please get in the comments and let people know about it. If you like the video, please click like. Please subscribe to the channel. Really appreciate everybody that has already subscribed to the channel. It keeps this channel moving. And if you want some alerts, click the little bell when the next video comes out. This will conclude the video series on setting up my experience in setting up the Onefinity. If something else gets added on the machine or something like that, I'll add another video out. So keep woodworking, keep CNCing, and hope you guys have a good day.